Here we have problem number 9. How much energy is required to lift 8,000 kilogram space vehicle from Earth's surface to the height of the 380 kilometer above the surface? Okay, so basically we have a Earth. From the Earth we had object 8,000 kilogram. So we have to lift it to the height of 380 kilometers. Okay, we have to find how much energy is required to leave this object from initial position to the final position, which is 380 kilometers. So the mass of the Earth is given, radius of the Earth is given, and universal gravitation constant is given. So first of all, we know that potential energy in such a case is equal to the negative of the g mass of the Earth, any mass, divided by the radius of the Earth. This is a general formula, okay? So the minimum energy required is basically change in energy, okay? Change in energy of the potential energy is equal U final minus U initial. U final is equal so this distance from center of the Earth till this final is basically radius of the Earth plus this height, okay? So the formula will be negative of the g mass of the Earth, mass of the object, divided by the radius of the Earth plus height, okay? Then negative of the initial potential energy will be in the bracket negative g m mass of the Earth, mass of the object, divided by the initial position is just the radius of the Earth. So by plugging numbers, you will get how much energy is required to lift the object to that height. Okay, now let's look at the problem number 10. So we have to calculate initial speed of the object of mass 3 kg launched from the Earth's surface to reaching the speed 13,800 meters per second at very far distance from the Earth. Okay. Now, when the problem says that at far distance, we can take that distance as an infinite, okay? So what we have? So we have the Earth, we have the radius of the Earth, mass of the Earth, we have a rocket here, it launched at far distance, the final velocity of the object is 13,400 meters per second. So we have to find what should be the initial velocity so that it can reach at far distance this velocity, okay? We have to use conservation of the energy. Energy initial should be equal to the energy final, okay? So what we have for the initial energy? For the initial energy, we have kinetic energy plus potential energy initial, and then for the final, we have kinetic energy final and potential energy final. So initial energy of the kinetic energy will be mv initial squared over 2, and then potential energy initial is gm mass of the Earth, object mass divided by the radius of the Earth, okay? Then the final energies will be mv final squared over 2, which is kinetic energy final, and then final potential energy at far away. So here should be the distance should be basically r Earth plus infinite. So since it's going to be infinite, so all this potential energy final becomes a 0, and that's it. So from there you just have to find what is the v initial. So by doing so, you get the final formula, which is this one. By plugging numbers, you can find that you need such an initial velocity of the rocket so that it can reach this final velocity at infinite.